Today we speak about the MDTools library. My intent is to provide you some basic information of how to handle cavities and footprints in the library. And today we try to build a custom footprint in the library, in the cavities. Let's start with explaining the environment. So on the top right, we have the settings. And we have two important tools here. The first one is the real setting, so where we are working. And so in this case, you can set the library you are working on. And the setting for the plugs is basically the position repository where you have all the 3D model for the plugs. In this part of the library manager plugs, it is possible to link cavity and plugs. We will see later. So these settings, this plug model library is only a path where you expect to find the plugs that later you will map with the corresponding cavities for the construction plugs. This has the purpose to make an automatic assembly in MDTools environment for the construction plugs. If you are using Inventor version, it is also possible to use the Vault server, so it is possible to connect directly to a Vault server. If you are using a different PDM system, I recommend you set the local system and you put the path as your current workspace in your PDM environment. And I recommend you download all the files that you need in the workspace in the local machine. So let's move to the second item here, and which is, let me always highlight it. This one is a tool that allows you to import cavities from other libraries. So for new MDTools users, you always get the latest library. For older new users, you may have a library that is missing several cavities, and we regularly deliver cavities if demanded by our customer. So by using this utility, it is possible to find out another library MDTools which you can get from your customer, from your supplier, or from VEST directly. Let me make an example. I can go to my MDTools libraries. I can take my, I don't know, MDTools HIDAC. I don't know what it is. Inside the source library, I can filter by folders. Let's say I need the BSP ports. I can select all and I can import. I'm not doing that. I already have these cavities in my library, but basically, if you need the cavities and you know that someone else has the cavities in a different library, you can just use this tool to import cavities from one library to another one. Please notice these two flags: create library if not present and overwrite cavities if present. Basically, if you don't have this folder in the library and you don't check create library if not present, then a library manager will not import anything. In addition, if you already have cavities with the same name and you uncheck this, then the original cavities you have in the library will stay where they are. Okay, that's all for this, and now we started with something more practical in the cavities. So the library manager is divided into different parts. Cavities is where we find all the geometry definition for cavities, footprints, ports, bolt holes, and so on. Then we have o-ring, groove definition, slots, component outlines, plugs, tools, and materials. Let's focus on cavities. It is possible to search by cavity name. Let's say that we need a Parker C10 C10-2, then in this case, a library manager will look through all the cavities sorted alphabetically in the library and will find what you're looking for. So there is a way to find the cavity by name. It is possible also to filter the cavity by type. So I want only the ports. I want only the flanges. Or, which is the common way I use, is I can switch to a particular folder. Let's say I want Toniella, or I want Parker. And if you click on a cavity, you can see the cavity details. As you can see here, I have a slightly different naming with respect to the standard library. So I put a 0, 1, 2 in front of some folders. This is just to make it easier in my MDTools environment to find the cavities that I need. It is possible to rename cavities. If you need to rename folders, if you need to rename a folder, just click here. You select the folder that you need. Let's say I need a fluid press, and you can put a prefix in front of it. And I can click rename, and yes, confirm. And now fluid press will jump to alphabetically to item 2, fluid press. It is also possible to create a new folder, and let me call it webinar series, and I create a new folder. So now that I did that, in my libraries, I will find also a folder called webinar series. And inside this folder, I don't have anything. So let's start understanding a bit of the type of cavities by importing some cavities inside here. So it is possible to add new cavities in any folder by using the add. I never, and except for training, I never start a cavity from scratch, because basically you always find something similar to what you need to do. So I basically prefer to import a cavity. So when you click import cavity data, basically you see the list of all the folders that you are working on. And let's start importing maybe just a bolt hole. So I go to my bolt hole and I take an M10. Okay. So this cavity type is the bolt hole cavity type. So for each cavity, you can define the cavity type. And we have the bolt hole, the cartridge, the port, the drill hole, the bolt and flange interface. Bolt hole is anything in a cavity that has no hydraulic function. In this case, it's just a bolt hole, a bolt M10. You can change the name. I recommend not to have 2 cavities with the same name in different folders. This is not convenient, because then when you search for that name, you will find 2 or 3 instances of the same cavity. So let me call it M10 webinar. And you have also M10 webinar is the name of the cavity that you will be finding just by typing in MDTools the cavity name, and is the name that you must specify to the component that is needing it in HydroCAD library. You have also a place for OEM name. So here you can put really whatever you want that helps you identifying the cavity. Each cavity is then made of different steps. In this case, I need only 2 steps. There is nothing much to say, except that we can define the thread definition here. So for the step 0, we have an M10, the pitch, and the class. And really here you can put whatever you want. The machining sequence is very important, because this is defining how this drill will be represented in a machining drawing in MDTools in terms of machining callout or drill chart. Let's say that we like this definition and we click save. So in this case, as you can see, MDTools Library Manager added a library on my webinar series that is called M10 webinar. Now let's add a new cavity, and now I import a cartridge valve. Well, let's start with a port. Let's say that I need a BSP port, G1x2, and we understand how the ports are made. So again, port type. Now this is a slightly more complex geometry, although it is relatively simple in any case. It is made of some steps. A port is a geometry that has hydraulic functions in a block. In fact, we can see on the right that we have some coloring for these ports. So to define where this working area, so technically for MDTools, this is what we call a working area, and the gray is the dead area. So when MDTools is saying there is a dead area, working area intersections, it means that there is a collision between a gray part and the color part. So to define where the working area is starting, we have this information here. Basically, it is the insertion depth. So if we change insertion depth, let's say we make it 20, we can see that the color is changing on the right. So insertion depth is controlling the position of the working area for a port. In addition, head height is the height of the normally the cap of the plug. So if this port is used as a construction plug and you wanted to deepen the spot face in order that you don't see on the face of the manifold the geometry of the plug, this is the value that you must sync, 8.25, and you can change it, let's say 10. And when you use the flash command in MDTools, it will deepen by 10 millimeters, that particular cavity. In addition, for the ports, we have the maximum pressure, which is basically a value. If you are in metric unit, this is considered as bar, or PSI if you are using an imperial library. So here you just put the value. And in this case, there is a command in MDTools that will verify if the construction plug is fitting, is matching the maximum net pressure of that particular design. On the right, we can see some information that will be applied to that particular cavity. And for instance, we can put a tool number 1, 2, 3, 4, 5. So this is highly customizable. You can put whichever information you want. Please notice that this information, $step 12, $step 0, $step 1, refer to a diameter or depth of the corresponding steps in the library. So here we have the step. When we write in the depth $step 1, let me change the color, $step 1 for the depth. That means that MDTools will take the step 1, will take the depth 15, and we expect to have this depth 15 plus 1. So in the machining drawing, we will see 16 in the depth. And that's exactly the depth for the G1/2 thread. So this is the thread. And the depth of the thread will be step 1 plus, in this case, the spot face. So you control which attributes you want to display in the machining drawing by using text or $step 12 or 1 or 2, whichever step in the cavity profile you need. And MDTools will display the value in the either machining callout or a drill chart in the block. Let's save this cavity as G1/2 webinar, and we save it. Let's move now to another more complex type, which is the cartridge valve. It is possible again to start from scratch, but we import a cavity that is similar to what we need to do. Let's go to Parker. And we take a suite and S2. Now we see that this is a cavity, a cartridge valve. The name is this one, and we change it suite and S2 webinar. We can specify node, catalog, whatever we need. Like for the other geometries, we have several steps defining the different diameters and depth to build the cavity profile. When you click on each line, you will see the corresponding diameter and depth on the right. For cartridge and also for ports, there is an important parameter which is down here. Maximum drill diameter and step 12. So maximum drill diameter is conditioning the maximum value you can accept on the pilot drill of a cavity. This is applicable to any standard drill or any port or any cartridge valve. So you have a standard value that is used when you place the cavity in the block. This value can change when you use the connector to cavity, but this value will never exceed the maximum drill diameter unless you force. When you try to make the step 12 larger in diameter, MDTools will give you a warning. In addition, a cartridge cavity, has some other information, which are basically the number of ports. This is a two-way cavity, and you can control the port number and port diameter if needed. So for instance, in this case, this is port number 2. This is the depth from the spot face, 17.96. This is the diameter. In this case, it is a radial intersection. In case you need a port that is going from a certain dimension to the end of the step 12, then you leave the port diameter blank. And this is just the starting point. Let's say I change it to 40, and now you see that it changed the starting point for my port 1. Connecting cavities, here you can type whatever you want. It's not relevant for the design. If this is just maybe a cavity for a relief valve, you can type in pressure, and tank. In some case, for some special valves, you have drain, pilot. This is just a note that you can use, but has no other importance in the design. Again, like for all the other items, we have the machining sequence that will be displayed in the machining drawing in terms of machining callout or drill chart. Let me save also this cavity. The simplest cavity we can find in MDTools is this drill. So let's add a drill. We add an import from the drill hole. We just add a 12mm drill. So this is just a standard drill. And as you can see, it is the most basic item. And it is made just by a diameter, depth, angle, and a very simple machining sequence. A drill is supposed to have a working area across all the drill depth. So a port has a dead area on top and a working area starting down, while a drill is only working area. So for instance, for an expander plug, you don't use the drill. Let me show you. Let me import an expander plug. MB600. So the expander plug is not using the drill type of cavity, it's using the port type of cavity. Although it is a very simple geometry, just 2 steps, but we need a dead area on top in order to verify connections in the block. Let me import, instead of these geometries, which are very basic, let me import a footprint. Well, no, let's build a footprint from scratch. So I have a small drawing made with Hydro. This is really something that sometimes you need to make a custom footprints in the library, because this is be a special valve that you need in your design. So let's study a bit, and we try to build this in our library. So this footprint is made of 4 bolt holes, and they are 4 M10. Then we have 4 ports, P, A, B, and tank, with maximum diameter. We have all the dimensions, and we have also an outline, a component outline. So let's try to build it in the library. We need to, when we start building a footprint, we need to define the origin of our footprint. In this case, I will take this bolt hole, because all the dimension starts from there. So this will be my origin. So the first cavity for my footprint will be this one, which is an M10 by 20. So I will just go here and import. Let me clean up my drawing. I imported this M10 webinar. Okay, this will be my first cavity. Let me call this cavity as a custom footprint webinar. And I now save it. So now I am creating a custom footprint, but it's not a bolt hole. I will turn into an interface pattern. And when you turn into an interface pattern, something different happens here. So now, as you can see, it is displaying this primary cavity. So this is the first cavity of the footprint, and it is a bolt hole. This is perfectly fine. And I just click Save. But when you define a footprint, in addition to this small dialog, you see also the edit footprint data down here. So basically, a footprint is a group of different cavities belonging to the same set of drills. If you click Edit Footprint Data, you enter in a second dialog where you can put all the additional drills. Let's get back to AutoCAD. So here we have the pattern is 130 and 80 millimeters. So let's start building all the 4 bolt holes. Again, we can import the same M10 webinar. So it is importing this geometry, and we can define the distance. So on the X, we have 130 millimeters and 0 on the Y. And we click Save. And now we see 2 cavities showing up here. This is the origin of the cavity, and now this is the new cavity. In green, you always see the parent cavity of the footprint. Now we go to the other one, which is 130 minus 80, and we do a Save As. And then we do 0 minus 80, Save As. Now we have built all the 4 pattern. And it is very easy when importing cavity, because once you define the first cavity, then you just use Save As and create all the different identical bolt holes. Now we want to add the component outline. So to specify the component outline for our cavity, which is that rectangle, we must go to the BH1 and click Edit Outline here, down here. When we click Edit Outline, we define the type of geometry we need. It was 160 and 100. Then I think it was 85. We see if this is the case. Let me verify. 15 and 90. That's not correct. 90 and 15. This is the origin of the footprint. So in our case, it's on the top left. So this is the distance, and we click Save, and we will see the preview. If it is not correct, we get back and fix the position. And then we can save, so that now the outline is saved. Now let's start placing the drill holes. Erase drawing, and we go back to, so this drill is minus 1825, and it is a 20 millimeter. So we add a new cavity, we import a drill hole 20 millimeters. The port name is P, that's our P port name. The position is, it was mine 18. Well, I don't remember, my memory is 25 minus 18. 25 minus 18. And we click Save. And now we have the first drill. And something else, the maximum drill diameter is 20. This is very important, because we don't want this drill to be exceed that 20 millimeters. And then we go back there, and we have the 103 minus 66. 103 minus 66, and we click That's our tank port, save as. And now we have the other port. And then we have the A and B, which are minus 6649 and minus 1881, 4981. So we have a port, 49 minus 66, the diameter is 16 and 16, and we do a save as. And the B is B port is let's check, 81 minus 18, 81 minus 18, save as. Now that we have created our geometry, we can close and we can save our footprint. Now we can go and test it in Inventor. And since we are almost out of time, now we will make a second session for Library Manager next month. So let me start a part so to quickly verify what we did for our footprint. Let me load MDTools. We start with a block. We create a block, a 200 by 100 by 100. And we go into the folders and we will find our webinar series folder. We can find our custom footprint webinar. We can see that our custom footprint has all the ports A, B, P, and T. So we can define some net. Let's say that's A, B, P, and T. That's the component webinar series. And we can insert in the block. We can see the preview and click OK. And this is adding in our block that footprint that we have just created. We can test out also the other cavities that we have created. We have the cartridge valve. We have the custom ports that will work and can be connected in the center with another cavity. And we have also the bolt hole. If we save and make the machining drawing, let's do quickly. That's MLM. And go to the machining drawing. We can create the views of our block. And for instance, if we create the machining callout for all the drawings, we can see that we have exactly those dimensions that we defined. Tool number 1, 2, 3, 4, 5 drill G1 by 2. This is the customization we made in our library. And here we have the diameter and depth, diameter and depth. So for today, that's enough. Sorry for going a bit longer than expected. Next month, we will check a bit of all the other parts of the Library Manager. I turn it over to John.
Thank you, Carlo. So, hey, just one quick question. Maybe we have a global audience on. So, is there some discussion about the dot versus comma separator? Do we want to leave that to session 2, or do you want to mention that today?
Basically, when you install MDTools, it will ask you which library you want to install. And the word is divided into two. Those that use the dot as decimal separator and those using comma as decimal separator. So I am in the comma side. So as you can see, that's maybe small, but that's 8,5. And so due to the fact that someone is also used to use fractions, really it is not possible at present in MDTools to have one unique library for both comma and dot. So there will be two different libraries. And if you have a library with comma, you will not be able to import cavities with dots automatically. You can ask us, but it will not be possible, and vice versa. If you need to use a dot separated library in your system temporarily, this is what I frequently need to do for support, because I have customer using dot and customer using comma. I just change my decimal separator in the operating system. For the user, really, once you set up the correct library, that's not a problem. But when you install for the first time MDTools library, make sure that you install the correct library. Otherwise, really, there is a risk that you will not be able to create any geometry, because simply the decimal separator will be ignored.